This is lesson 3.2.5. How can I solve complicated equations? Distributive property equations. Not all equations are as simple as the equations you have solved so far. However, many equations that look complicated just need to be broken into simpler, more familiar parts. In this lesson, you will use algebra tiles to work with situations that combine addition and multiplication. Then you will solve equations that contain complicated parts. Please label your notes day 3.2.5. This is problem 3-108. Use algebra tiles to build, draw, and simplify each expression. Here is letter A. It says 3 parenthesis x plus 4 parenthesis. What that means is you have 3 piles that each include an x plus 4. So please pause the video and draw this out. Okay, next we're going to simplify this, and what that means is we are going to combine the like terms to see what we have all together here. When I do that, I see that I have 3x plus 12. Please draw this picture. Problem B says 4 parenthesis 2x minus 1 parenthesis. That means that you have 4 piles and each pile includes 2x minus 1. To simplify that, we are going to combine like terms. And I see what I have is 8x minus 4. Part C says 2 parenthesis x plus 5 parenthesis, and then it has a plus 3. So that is what's shown here, 2 piles that each include x plus 5, and then there's an extra plus 3 at the end. So now to combine like terms, I would start out with just putting all of these together, which would be 2x plus 10 plus 3. And then I would combine those like terms, and now I've got 2x plus 13. Part D says 3 parenthesis x minus 2 parenthesis, and then has a plus 5. So this is 3 piles that each include an x and a minus 2, and then at the end it's also got a plus 5. So I'm going to start by combining like terms. Now I've got a 3x, a minus 6, and a plus 5. And then I'm going to combine like terms more, or I'm going to do 0 pairs actually, remove 0 pairs. If I remove 0 pairs, that is all of this, a positive 5 and a negative 5. Remove those, and my final answer is 3x minus 1. Problem 3-109. You used the distributive property to rewrite problems with parentheses similar to the ones above. Use the distributive property to complete and simplify each expression below. Read the math notes box at the end of this lesson if you need help getting started. So what we had was 2 piles of x plus 5. So we had 2 of everything inside the parenthesis. We had 2 times x and 2 times 5, or that would be 2x plus 10. Part B, 3 times 2x, 3 times 1. So if I have 3 piles with 2 x's each, that's 6x, and then 3 times 1 is 3. Now this works with negative tiles too, negative on the outside. It just means that they're in the opposite region, and we end up flipping them all up. We're going to do negative 2 times x and negative 2 times positive 3. So negative 2x, and then negative 2 times positive 3 is negative 6 or minus 6. Part D, negative 3 times 2x, and I've got a negative 3 times a negative or a minus 5. So, and negative 3 times a negative 5. Negative 3 times 2x is negative 6x. Negative 3 times negative 5 is a positive 15. Problem 3-111 says solve each of the following equations for x. Show your steps and check your answers. Part A, before I start solving that, I wanted you to see what 3x minus 2 parentheses 5x plus 3 looks like. I've got 3 x's in the positive region, and then in the opposite region, I've got 2 piles that each include a 5x plus 3. So what I will be doing is I will be flipping these up into the other region, into the positive region, and I have to make up the opposites for each one. So after I flip it up, that's what I have, and then I'll start to combine like terms. So here is my problem that I'm going to solve here. I still have my 3 x's. When I flip up 2 piles of 5 x's, I have negative 10 x's. And when I flip up 2 piles of 3, that would be a negative 6. On this side, so far I've done nothing. Now on the left-hand side, I'm going to combine my like terms. My like terms are my 3x and my negative 10x. When I combine those, I get negative 7x. I still have my minus 6. And on this side, I haven't changed anything. Next, I need to decide what I want to move. Me personally, I like to move the smallest x first. If you choose to do it a different way, you're probably fine. We should get the same answer. I'm going to add 7x to both sides. My negative 7x, positive 7x, those cancel out. I've got negative 6. I have not put anything with that 14. And now my negative 2 and x and my positive 7x would be a positive 5x. Now I want to get rid of everything that's on the same side as the x. So I'm going to get rid of this positive 14 by taking 14 away, doing it to both sides. Negative 6 minus 14 is negative 20. Positive 14 take away 14. I still have 5x. I've got 5 x's and I want to get them all by themselves, so I'm going to put them into 5 different piles. On the left-hand side, negative 20 put into 5 different piles would be negative 4. And then 5 x's put into 5 different piles will be just a positive x. So I believe that my answer is x equals negative 4. Now I'm going to check that. In order to check that, I'm going to put a negative 4 in place of every x and see if I get the same value on both sides. So 3 times negative 4 minus 2 parenthesis 5 times negative 4 plus 3 parenthesis. Is that the same as 14 minus 2 times negative 4? You could plug this right into your calculator and see what you get, but you need to be really careful. This would be a negative 12. I'm not going to do anything with that right now because I need to simplify there. Negative 20 plus 3. And this is a plus 8. So still not going to use that distributive property because that's negative 17. You can do the distributive property or you can do order of operations and do parentheses first. This is 22. So negative 12 plus 34. And I do get 22 on each side. So I know that my answer, x equals negative 4, is correct. Here's problem 3-111 part B. Please stop the video and solve this one on your own. Okay, when I solve this, first thing I'm going to do is the distributive property. 3 times x, 3 times 1. I still have that minus 8. On the right-hand side, I've got that 14. Now with this minus here, that means everything's in the opposite region, so I have to do that negative 2 times 3 to flip it up, times 3x, I mean, so negative 6x. And then to flip up this negative 4 and have two piles, negative 2 times negative 4 would be positive 8. Next, I'm going to combine like terms on each side. So I've got a positive 3 and a negative 8. Combining those, removing 0 pairs, that would be a negative 5. On the right-hand side, I've got a 14 and a positive 8. That's 22. Still have that minus 6x. Now, like I said, at this point, I like to move my smallest x next. So I'm going to undo that minus 6x. I'm going to plus 6x on both sides. Minus 6x plus 6x, that cancels out. I want to get rid of everything that's on the x side. I'm going to undo that minus 5. That cancels out. 9x equals 27. Divide both sides by 9. X equals 3. I'm going to check that answer now by putting a 3 in everywhere that I have an x. Okay, 3 times 4 is 12. 12 minus 8 is 4. This is 9 minus 4, so that's 5. So negative 2 times 5. 14 minus 10 is 4. I get the same value on both sides, so x equals 3 is a good answer. Here is how we write the distributive property algebraically in the math notes here. It's a times the quantity b plus c, that means in parentheses, b plus c, is equal to a times b plus a times c. So when A multiplies a group of terms, such as B plus C, it multiplies each term of the group. For example, when multiplying 2 times the group x plus 4, 2 multiplies the x and 2 multiplies this 4. This can be shown as with the algebra tiles. We've got 2 piles of x plus 4. 2 times x, 2 times 4 equals 2x plus 8. Your assignment today, part of it is 3-117. It does have a checkpoint problem on there. Remember, here's what the book says. At this point, you should be comfortable working with these types of problems and can solve them correctly. If you feel that you need more confidence when solving these types of problems, then review the checkpoint 3 materials and try to practice them. Try the practice problems provided. From this point on, you will be expected to do problems like this correctly and with confidence. Here is the rest of the checkpoint problem. In the book, at the bottom of this problem, there is a link. That link has the answers to these questions. It has how to work out these questions, and it has additional examples and answers if you feel like you would need more practice or more help with these. Your assignment is day 3.2.5. It's problems 3-113 to 3-117, and if you're in the regular math book, it starts on page 140.